Lesson 72, Pyramids and Cones. First, something a little bit different related to what we were doing in the last lesson. We had talked about factoring out trinomials and how before we try to split a trinomial into two binomial factors, we want to make sure we remove any common factors. When we're doing this, we could also have a binomial as that common factor. So if we look at this example here, x squared times x plus y minus 6x times x plus y plus 9 times x plus y. Each one of these terms here has x plus y as a factor in it. So before we try to factor out this binomial, the first thing that we want to do is remove that common factor from each of these terms. So we get x plus y times x squared minus 6x plus 9. And then at that point, we'll just factor this trinomial like we would before. So find two numbers that multiply to positive 9 and add to negative 6. We'll find it's negative 3 and negative 3. And so we get x plus y times x minus 3 times x minus 3. Be careful that you keep this x plus y in there. That's still one of your factors. It's just that we removed it before we factored out that trinomial. All right, pyramids and cones, a few terms first. A pyramid is a solid, so it's a three-dimensional shape we're talking about, where one of the faces is a polygon. We call that the base. And the other faces, or our lateral faces, our side faces, are triangles that meet at a common point, which we call the vertex or the apex. So we see here the base, you've got this lateral face here as a triangle, and all of these triangles, these lateral faces, meet at the apex or the vertex. Easy way to figure out which one's the base, if you're not sure, is that if there's one which isn't a triangle, that'll be your base. The height is going to be the distance from the apex or the vertex to the center of the base, so straight up and down just like that. A regular pyramid is where our base is a regular polygon. Those are the only kinds of pyramids we'll be dealing with. And a right pyramid is one where the vertex is directly over the center of the base. So just like you notice here, the center of the base is here, the apex or the vertex is directly above it. It's not slanted over. There are pyramids like that, but we won't be worrying about them. So all our pyramids will have the vertex directly over the center of the base, and also each side of this base will be the same length. It's a regular polygon, all sides are the same length, and so those will all be the same. For cones, cone is like a pyramid, except that its base is a curved shape. We'll primarily be dealing with, actually exclusively, with circular cones where the base is a circle. And for cones, we don't have lateral faces because it's smooth there, so instead we talk about this distance, the slant height, which is the distance along this slant from the vertex to any point on the edge of the base. It'll always be the same since this is a circle here, so the distance is always the same. Volume. To find the volume of a pyramid or a cone, we have the same formula. 1/3 times the area of the base times the height. So if we take this right rectangular pyramid here, its base is 12 feet this way and 6 feet this way, and its height is 15 feet. So to find the volume, first we find the area of the base. It's a rectangle, rectangular pyramid. And so the area of the base is length times width, 6 times 12, or 72 square feet. The volume then is the area of the base times the height times 1/3. So 1/3 area base times height, 1/3 the area of the base we said was 72 square feet, and the height is 15 feet. 1/3 of 72 is 24. 24 times 15 gives us 360 cubic feet. Remember, anytime we're talking about volume, we'll always have cubic units. Now let's do an example with a cone. This right circular cone has a base with a radius of 3 meters and a height of 7 meters. What is the volume? Again, volume is 1/3 of the area of the base times the height. So first we find the area of the base, which here, since it's a circle, is pi r squared. Pi times the radius squared, 3 squared, is 9 pi square meters. We multiply that by 1/3 and by the height to get our volume. 1/3 times 9 pi times 7, or 3 pi times 7, 21 pi cubic meters. Again, using cubic units because this is volume here. Surface area of pyramids and cones. You should have known this was coming. For pyramids, we'll find the area of the base and the area of the lateral faces. So if we think of this pyramid here, that base is part of the surface, and then the rest of the surface is these lateral faces there. And we're just going to add them all together. So in this example, we've got a pentagonal pyramid. It's a pentagon, it's got 5 sides as our base. The area of the base is 28 square inches. Each side of the base is 4 inches long, and the height of each lateral face is 5 inches. So it's 5 inches along that triangle there. So now the base, they've already given us the area of. Now we need to find the area of the lateral faces. Well, there are 5 of them, and they're each a triangle. So it's going to be 5 times our formula for a triangle, 1/2 base times height, or 5 times, in this case, 1/2, 4 inches, there's your base, and 5 inches is the height. 5 times 10, or 50 square inches for all of those lateral faces put together. Notice because we're multiplying by 5, so we get all 5 there. We add this to the area of the base, which we said was 28, and we get our surface area, 78 square inches. For a cone, it's going to be a little bit different because we don't have faces there. There's just the lateral area, which doesn't have any faces to it. So it'll still be the area of the base. And to find the lateral area, instead of adding together the areas of the faces, the formula for the area of that surface is pi RL, where R is the radius of the base, and L is what we call the slant height. So this measurement here, going from the vertex to the edge of the base. So in this example, the radius of the base of the cone is 8 centimeters, and the slant height is 9 centimeters. What's the surface area? Well, we find the area of the base. It's a circle, pi r squared, so 64 pi square centimeters. And then the lateral area is pi RL, so pi times 8 times 9, or 72 pi square centimeters. We add them together to get our surface area overall, 136 pi square centimeters. Notice that since this is surface area, we're dealing with square units rather than cubic units.